Can you hear me? All right. Sweet. So I'm here to talk about streamlining background checks at scale. Not the whole entire background check, just a very small part of it, with a fine-tuned classifier on Predibase. So that's me, Vlad Bukhin, staff ML engineer. Here's just some of my interests. The common theme is optimize. Agenda. So I'm going to talk about the problem space and challenges, and then some LLM solution iterations that I did before fine-tuning, and then some experiments with fine-tuning process, and then what my results look like on production on Predibase. So the problem space. First of all, what's Checkr? Checkr runs background checks. We create reports. You get, a hiring entity runs a background check on a candidate, creates a report. We try to be fast, smooth. I borrowed this from a marketing deck, so it's just very nice. Smooth and safe, so we try to maximize accuracy and compliance with every hire. But today, we're going to be looking at automated adjudication. Adjudication is what happens after the background check. So we get all the data, right? And then we need to do something with it automatically to say, hey, hire this person, don't hire this person. And there's some manual review that could happen if we don't do our jobs very, very well. So, we're going to fine-tune something, so we have to talk about the data a little bit. I mean, with any machine learning problem, I feel like you can't really do anything until you talk about what it is the data is. So basically, we run reports, and a report can come back with a record, and that record can contain several charges. But who creates those charges? Okay, well there's legal documentation and by state, but the district attorney writes that documentation. It could be a court clerk that writes that documentation. But then that's not where it ends. They submit it to the court. Now the court has an interface. Could be a human interface, could be an electronic interface. And then still not the end. There's a vendor that could be getting that data for us manually from binders. Okay, so there's a lot of variance in this text data that comes from legal docs. So a little bit more about the problem. There's 1.5 million reports, checks per month. And 98% of these charges, they're pretty simple, right? It's it doesn't take an advanced ML algorithm to solve it. But for this last 2%, it's pretty complex, and it's complex for humans to do, and it's complex for models, some of the naive models to do as well. So the task is to classify these charges into 230 categories so that they can be used for customers to adjudicate automatically their hires. And then this part of the annotation of the background check is done synchronously, okay? And could we do this with an async, have an async platform, put the request on Kafka, come back? We could do that, but we're an industry, and so you don't want to spend resources doing things that you don't want to do. So it would be nice for it to be synchronous and quick, right? Okay. So over here on the right, there's a graph. This is a Predibase graph. I think they just created this interface a couple of weeks ago. And you can see that I just want to show scale a little bit. There's constant traffic, one request every 3 seconds, but it can be up to 2 requests a second. Small amount of tokens out because it's a multi-class supervised classifier, right? So, and then about 75 tokens on an average going in. So that's the data that we're dealing with. And so when I first got onto this project, when I inherited it, right, as we do in industry, we all work on each other's things. So there was a logistic regression that was doing 98% of the work. Then there was a deep learning model that was doing 1% of the work. And then there was 1% that was unclassified because the accuracy was really, really low. We can't serve that answer to the customer because it would make mistakes too often and would auto-adjudicate incorrectly, lawsuits, blah, blah, blah. Okay, so just to recap the problem really quick, customer frustration on the last 1%. We want to be more accurate. We want to avoid async architecture, and we want reasonable inference costs. So now I'm gonna talk about some solutions iterations pre-fine tuning. So the one thing that I kind of learned while doing this is I banged my head against the wall a lot until I just developed the right data set. So I inherited a training set and an evaluation set, but I made it better, and I made an even like another evaluation set that kind of was targeted to my 2% that I wanted to classify. If you work on your data set early, there's a lot of reward. Establish correctness, you guys have probably already heard this a lot, but you can do that in many ways. For a multi-class classifier, that's easy because it's just an exact match of text. But SEM scores or using an expert LLM to evaluate, as a function to evaluate your correctness, I think is key. And then once you've got that, define your metrics so you just can compare your experiments, right? That's very, I think like with LLMs, nowadays people try to do prompt engineering and they're kind of walking away from the ML lifecycle, the ML experimentation platform. But I think it's useful, and I think it's more fun to use to create a platform. So what I do is I create a grid search, and I have the input data, output metrics to be able to compare my test experiments. But then my grid search, it can include, models, vendors, different prompts, hyperparameters, and best of all, different design patterns. And you could always go back and test something that you've tested before if it's all in your grid search. You don't have to grid search everything at the same time, but all of these elements in your kind of little platform helps. So what I tried specifically is the expert LLM plus RAG, and then the fine-tuned version. And that's after the logistic regression and deep learning, right? So the expert LLM using GPT-4, this was kind of earlier in the year, it gave me a really good result. I mean, 87%, 88% on just the charges alone. This is a really great result just from GPT-4 without any fine-tuning. And then for the more difficult side, it was around 80 to 82%, which is also pretty good. Then when I tried expert with RAG, and so basically with just expert, it was charge, instructions, and then the 230 categories, right? So you can assume that's kind of a lot of tokens. And the round trip time is pretty large, 15 seconds, and around a $12,000 cost per month, which I think is a lot for kind of a small use case. And then expert and RAG worked better, right? So now on my very representative of production set, it got a 96% accuracy, but then it actually went down with RAG because in the more difficult unclassified set, it was showing examples pointing the model in the wrong direction, basically, and it would guess wrong because semantic search was basically not giving it the right results because the unclassified set is the training set doesn't represent the unclassified set, so the lower accuracy in the unclassified test set. But then I fine-tuned a Llama 2 7B. Again, this was earlier this year. And the results were better in every column. Okay, so I went to 97% in the golden test set, 85%, which is a really big jump for us in the unclassified set. Really fast, right? Half a second or less, generally less, and per request, and then a cost of less than $800 per month. I also tried other design patterns like fine-tune plus expert, so get the fine-tune result plus validation from the expert if the model result was uncertain. I also tried consensus, which is basically using the fine-tune model twice or two different fine-tune models, and I didn't get a lot of gain. I'm surprised. Maybe I could keep digging, but in industry, you gotta concentrate on the customer. So those are my initial results that I couldn't get quite to work almost any better with those two approaches. Another kind of interesting thing is okay, I've got this LLM, it works better than my deep learning. Well, can I just make my deep learning model better? Well, maybe, okay. So I started just using more, and so first of all, I executed the LLM inference on the deep learning set, and I got 8% better performance with the LLM. Okay, can I make the deep learning better model? And so I started using more complex, more latent embeddings and deeper and larger models. And and I got like slight, improved results. And I'm like, what am I doing? I'm not a researcher. I'm in industry. I'm trying to solve a problem. Why don't I just use the LLM instead of the deep learning model? Because I am just simply approaching that anyway. What is an LLM, right? It's a deep learning model that has complex embeddings. So I kind of threw it away. Maybe you'll have the same issues with your solutions, but I ended up just using the LLM after a while of attempting to get the deep learning model to have more accurate results. Okay, fine-tuning now. So I tested several mainstream open source models, probably the same ones that you guys have, Llama 7B, Llama 13B, Llama 70B, and the Mistral family. And then in Predibase, I don't know how many people actually have used the Predibase platform, but in Predibase, it makes it really easy to look at loss and to throw away some of the lesser performing models in the grid search. So I discarded those with either a high loss or low rate of convergence. And what I found is that Predibase has, in general, I think Ludwig has an early stopping parameter. And I got bit by that because my data set is very large, 150,000 rows of training data. And so I just, word of caution, sometimes if your model is not converging the way you want, maybe try without the auto-stopping parameter to see if you can reach a global minima versus a local minima. And then the other thing, just also working with deep learning models, they're sensitive to hyperparameters. And I found that when you're doing fine-tuning, it's not. So that's really nice. Okay, so now I've got a production model, and I want to make it better. And I try to do some prompt engineering, and I find that it does almost nothing. And it's frustrating, and there's positives and negatives to that. Now, I imagine that if I had way less data, the prompt would do more. But because I have so much data, it's fairly just basically recognizing the pattern at that point. And so good things and bad things. If you want to leverage your prompt, good luck. And that's kind of the bad thing. But if you don't want to spend tokens on your prompt, it's a really good thing because you're not going to be able to do too much with it. Okay. The other thing, it's a classifier. It's kind of nice to have a data set that's like, hey, the LLM's not too sure. I want a subset of data because the LLM's not too sure. Well, how do you do that? Another common strategy is providing a confidence interval using the sum of log probs, the exponent, right? And so let's say that's your confidence. But I found that it just gave me a very skewed distribution of just ones. It was confident all the time. And I didn't like that. I wanted a subset that wasn't as confident. So what I tried was just increasing the temperature and lowering the top K, because basically increasing the temperature, it gets more creative. You can get more creative, but then decreasing the top K, you'll have only like a set of options for it to use. And so it's still precise, but it gives me a larger distribution of confidence, which I liked. So, and then the one other thing is I used to use another vendor for fine-tuning, and they did full fine-tuning. And at a certain point in the beginning of the year, I tried both on Predibase and then on the other vendor, and I got better results with full fine-tuning. But then when I retried after the big push that they had a couple of months ago in Predibase, it was very similar results, and I was very happy, and so I switched over to Predibase. So another tidbit. So what does production look like on Predibase? So first of all, it's like there's a 5x cost reduction versus GPT. I mean, honestly, I don't know if we would have even done this. I don't even know if it'd be worth it to do, like using the other, like the expert LLM strategies that I mentioned before. But so I deployed a Llama 3.8 right now, instruct adapter. I forgot to mention, I really like that Predibase has the prompts, the vendor prompts on their own website. So the prompt templates. So it's really nice to be able to just use a standard prompt template when fine tuning. And so I have a half A100 with reasonable budget and space for another adapter for more solutions that Checkr has, which is really nice. very reliable fine-tuning strategies. I mean, when every iteration of the fine-tuning job has a consistent accuracy. So that's not always the case. I found with another vendor that wasn't always the case, so I'm really happy with that. So basically, I've achieved like a 90% accuracy on that very difficult set, which I'm very happy with. Lots of customer satisfaction. Oh, and just looking at the two graphs, very low inference time, 0.15 seconds of inference time on my production set, consistent traffic, right? And also looking at queue time is pretty negligible. So I know that I definitely have space on this machine for another adapter. Lastly, about Predibase, I've been getting first-class support. I hope you all have been too. Basically, questions are addressed within an hour, longer improvements made within a few days. And then I find Predibase just as the whole thing to be very transparent because it's on open source software. So if there is a problem, if there is a decrease in performance, you kind of know where to look in the updates in the open source software, which makes me feel really good. Quick to report and fix issues, and always educating. I mean, we're here today being educated and lots of webinars. I think it's a really good job of building trust through being at the apex of their craft, I think. And then just lastly, I like the website as well. I think, not every operations website is as good. So I like the fact that they have projects and versions and loss graphs right there for you. So props to the Predibase engineering team. And that is it. Thank you very much. And then also, reach out to me if you want to do more fine tuning and do machine learning and a job at Checkr.
Thank you, Vlad, for the talk and the kind words. Anybody have questions? Well, yeah, please, right there. And we'll just wait for the mic so folks in the live stream can hear.
Thank you. Great talk. Question. You said that the fine-tuned model was not sensitive to the prompt. Was the prompt giving few short examples or description of the classes?
Instructions.
Instructions.
My prompt was giving instructions because, I guess I didn't do few shot because I was already fine tuning. So when you fine tune, you already give the model 100. Whatever your data set. So I tried to decrease my token size so it's more performant.
Right over there. Yeah, please.
Hi, did you try fine-tuning on top of other open source models like Mistral, and did you find there's a difference in terms of speed of convergence and so on?
Yeah, so when I did my experimentation, which was not that long ago, I found that the small Llama 8 had the best accuracy. Also, there's the convergence, but then there's also actually testing it in production, because I find that the loss value and the convergence is one thing, but then you actually test it with your own data set after the fact, because you may use different hyperparameters. Like I mentioned, I used a higher temperature, low top K. So that's why I don't just completely throw away and I don't think you can completely compare one loss graph to another. I think you do, but then you once you've kind of selected the best ones, then you still have to test with your production data as though you would be calling it in production. And while doing that testing, I found that the Llama 8 was a better performer than Mistral and Zephyr.
Awesome. Time for one last question. And just for the questions, I might ask if you could introduce your name and what your role at the company. Cool, there you go.
Hi, this is Atin Sanyal from Galileo. I was curious to know, as you've started productionizing your applications, what challenges you're facing in the production side of things as you maintain these models and keep updating them.
It's funny to be in industry because I'm constantly pulled into different directions. So the amount of time I can spend, optimizing after, maybe this is something you guys feel from your companies as well, but it's like as soon as you have achieved something great for the customer, it's time to move on. But at the same time, the things that are in my mind are, again, still, how do I even do an even better job understanding when the LLM isn't sure, and even responding unknown when it isn't. So those are some of the things that I'm still concerned about and want to figure out. That's
Excellent. Well, Vlad, thank you very much again for the talk today. Really enjoyed it, and